Hi everyone. The first step we're going to make is to create a group with the name Fem Surface. We write it and we put apply. Then we're gonna create a mesh. We select action, create object mesh, the type surface. We select quad to the element shape, uh, paver to the measure, quad 4, and then select the entire shape. Put 1 in the value and press apply. Now we have our figure of mesh, and now we're gonna create an equivalence. We find equivalence, then put all and tolerance cube, and equivalence tolerance, put 0.005 and then click and apply. The next step is to verify elements. We select verify. We go to verify. And then we're going to select element to the object and boundaries to the test. We put on free edges and then click on apply. We see how our figure is different. The next step is to verify again an object. We're gonna use quad and the test is gonna be aspect. We use aspect ratio of 5 and then click apply. Now we're going to post a group and select all surface on the select groups to post and click on apply. Now we go back to our start show or model, then change the view to smooth and zoom into the top area. Now we're gonna create loads of force. We select force and then write dead load. Into the force vector we write 0 minus 150 and 0 and press OK. Select the application region and select the these points going to be point 44, point 48, point 1 and point 68. We just use these 2 points to the first dead load and click apply. And we see the forces that are acting on those points. Now we're gonna create the second dead load. And in this time in the vector we write 0 minus 960 and 0. Then press on the OK button and once again we're going to select the application region. We select this time the point number 1 and the number 68. I want to push on add button and then OK. and from at the final we're gonna push apply again. Now we're going to zoom out the shape and we are going to create another load. This time the name will be op static load. We write it on the set name and click on input properties. We're going to write 0, -100 and -100 again on the serve load, and press OK to then go to the application region. Select the geometry filter and select once again 0.1 and 0.68. We click on add and apply. You can see the forces on those points. Now we're going to create an inertial load on the type element form. Create force inertial load, and the type is going to be, as I said before, element uniform. The name is gonna be gravity, and go to input data, and in the trans acceleration we write 0, -386.4 and 0. We're going to click on OK and then apply. Now we're going to put a constraint at the corners of the frame. We go to loads BCs, create a displacement and nodal. And we're going to create displacement and nodal. Okay, we're going to write it fixed base on the new set name. Remember that for every space you need to use that symbol. Input data, and we're going to write 000 for translations. Then going to press OK and go to the select application region. Going to the application region, and gonna select the corners. It is going to be the point 148, the point 11, point 3, and the point 159. Add OK, and then now we're going to click on apply. Now we're going to select the ISO view, and we're going to go to display, and go to load BCs, element properties, and unselect show LBC and prop values. Click on apply and then cancel. The figure should look like this. Now we're going to properties and set some materials. Let's create an isotropic, and the name of the material will be aluminum, and go to input properties. The elastic modulus will be 10 E6. The position ratio is going to be 0.3, and the density will be 2.61 E minus 4. Go to OK and apply. We're going to create now a 2D shell. We go to properties again, select the 2D shell. Yeah, it's already over there. And we're going to the property set name will be all frame flange. We're going to input properties, and select the material as aluminum. The thickness in this case will be 0.75. Press OK and apply. Now we change the view to the front view. We go with preferences on picking and select and close entire entity. Now close, and we're going to select the members, which are the top and the bottom flanges that are showing this figure, as you can see, the top and now the bottom. Click on add. If we want to select both, we make the square over one, then press shift and make the other square. Click on add, and then we're going to press OK to go once again and press apply. Now we're gonna create another property, but first we need to go to preference again and go to picking as we did in the last step. We're going to set the new name, that is all frame web. Go to the material, that is aluminum, and the thickness will be in this case 0.5. Then we press OK, and we're going to select the region that is going to be the middle part. We draw a square and cover all those circles and press add, and then OK and apply. Then we're going to modify some load cases. We'll go to load cases, modify. We're going to select the right icon, create load case, but instead we're going to change to modify. We select default in the load case to modify and see that all the forces that we have create are there. We check the list and then we press cancel. After that, we're going to post a group. Go to group, post, and select groups to post, select FEM surface, apply, and cancel. You see the meshing figure once again. And now we're going to go to the analysis part, to the analysis tab, and select the entire model, full run, and on the solution type we choose linear static. We press OK and then press apply. A document is created where are all our results. We can see in this it's a notepad. We can see all the results that the software has found. We can check it. You can see there's a lot of information over there. And to continue to the modeling and create a deformation model, you can follow these steps, which includes the access to the results, create a deformation model, and it will look like this. Now we can see it on the shed smooth view, and we're going to create a fringe to watch how the figure can look like. I hope you enjoy it, and don't forget to like this video and leave a comment. Thank you very much.